Hey, welcome back. Sorry I am unable to be there in person, but thank you for your flexibility as we kind of prepare for our Unit 6 exam. Gonna try something a little different. I thought this would be a little more, hopefully, involved and a little more interactive as we start to prepare for the test coming up your way tomorrow. So, test, don't stress it. You guys did real well on the quiz. I'm sure the test will be no different, but I want to make sure everybody is prepared and nobody is surprised. So, just like normal, here is your test prep in terms of what you should expect coming back for class Friday. It's going to be 15 multiple choice. Those will be on Canvas lockdown, 2 points apiece. So 30 points coming from the multiple choice section. And there will be a small, short written part. It's going to be 15 nomenclature, or sorry, 10 nomenclature, either writing or naming. 2 points apiece. That gives us 20 points come from there. That's just like your quiz. Hey. And so we shouldn't be surprised as to what we're going to see there. And then on the back of that written part will be the ACT bonus. So 50 points total. That'll then leave us a week to prep for the final and make sure we're ready to go for end of the semester. More importantly is what you're responsible for knowing. And so this unit was pretty quick. We started with the ionic properties lab. And so we looked at all of the same properties we did for covalent. We should be familiar with those. We also have those to reference in our notes. We talked about how we actually go about forming ions, how we lose those electrons or gain electrons to become charged particles. We talked about that process of how we define our ionic bonding and how they actually transfer those electrons to become stable. And most of our time, a bulk of our time has been spent on the naming and the writing. It's a little more involved when we start to look at the charges. And so we spend a lot of time making sure that our charges add up to zero. We put the metals first, Roman numerals, et cetera, et cetera, et cetera. So I do want to give you a little bit of practice today. My suggestion would be I'm going to throw up a sample problem for you. You try it. So throw up a sample problem. You pause it, try it, see what you get, and then I'll actually come back with the answers so that you can check them with the video as we go. Don't just flip through this. That doesn't help you any. That doesn't help you prepare. So try it first, then check to see how you're doing. Cool. So my first question for you, what is the formula for ammonium phosphate? And once you've written that formula, how many total atoms are represented in that formula unit? How many total atoms in that compound? So pause it, give it a shot, see what you get. So ammonium, we're looking back to our periodic tables, NH4 1 plus. Phosphate is PO4 3 minus. We crisscross the charges. We're going to need 3 of those ammoniums. Remember to put it in parentheses. Where it gets a little tricky, and the reason why that's so important is for our next question here, when we go to get our total number of atoms, we would distribute the 3. There's 3 nitrogens, 12 hydrogens, 1 phosphorus, and 4 oxygen for a total of 20 atoms in this compound. So whenever we have a number outside the parentheses, it would multiply in, it distributes in. So 3 nitrogen, 12 hydrogen, be sure to multiply that, don't add them. It's not 7 hydrogen, it's 12 hydrogen, a phosphorus, and 4 oxygens. Cool, try this one. Without looking, what are the properties of our ionic compounds based on what we saw in the lab? Pause it. Hopefully you remembered they had a really high melting point. They're that nice crystalline structure. They dissolved into solution. When in solution, they then will conduct electricity, but they don't conduct electricity as a solid, just in solution. And we know that when we start to look at our kind of structures, they form those nice crystalline structures. Cool. If you would, draw the Lewis structure for the following particles. So give me a calcium, how many dots? And then how many dots for a calcium 2 plus? Pause it. Calcium, we know, is in the second column on the periodic table, should have 2 dots for the calcium atom. For the calcium ion, you would lose those 2 dots. So we'd have Ca2 plus with no particles or no Lewis dots around it. What about this one? Try this one. Pause it. Hopefully you drew oxygen with 6 dots around the outside. It's in the 6th column. When it forms its O2 minus ion, it gains an additional 2. Your O2 minus should have all 8 on its outer shell. It has a full valence shell for oxide, O2 minus. Cool. Which of the following would be considered ionic compounds, given what we've talked about in our last 2 units? Pause it. Cool. We know that in order for it to be ionic, it's got to start with a metal, but I snuck in a sneaky one. We know that as we look at the periodic table, our metals are to the left of the stair step. And so beryllium would be a metal. This first one is ionic. The second two are not. They both start with a non-metal, and so these would be covalent, and the naming would be different. We'll practice kind of mixing those up next week. The one that's tricky here is the last one. You should hopefully recognize NH4 as a charged particle. This is ammonium. It is our only ionic compound that doesn't start with a metal. It was kind of sneaky, but good to review it when we're looking at our ionic compounds. Cool. Use a Lewis structure to model the ionic bond process between sodium and chlorine to make sodium chloride. Think about your dots. Pause it. Try it. Hopefully, you started sodium with 1 dot. Chlorine had 7. You showed that electron getting transferred to the chloride. This is where we get that ionic bond. It is the result of the transfer of those electrons, creating ions, sticking our particles together to form our sodium chloride particle. Cool. Now we get into meat and potatoes, the ones we practice so much. Pause it, try these 5 for me, and then check your answers. Cool. Remember that when we're looking at our charges on our transitions, they need Roman numerals. That's the charge on that copper, not the number of them. We don't need them for aluminum, zinc, or silver. I'm going to leave those up for you for the test as well. Hopefully you got the following: CaBr2, KOH, Cu parentheses, C2H3O2, close parentheses 2, calcium phosphate, Ca3, PO4 parentheses 2, ammonium sulfate, NH4, 2, SO4. Make sure your final charges add up to 0. This, probably the more difficult version. It's a little bit easier to go the other way. Given these formulas, give me the name. Sorry, puppies in the background. Cool. As we're looking, remember for our transition elements, Fe needs Roman numerals. We all would not need them for the silver, but we would need them for the copper. And if we're trying to figure out the charge on that copper, you work backwards from the negative. SO4 is a 2- charge. Means you got to have 2+ at the end for our copper, but we got 2 of them. So each of those coppers would have to be a 1+. It would be copper 1 sulfate on the name on that last one. But here's the rest of your answers. We've got iron 3 sulfide, ide because it's just the S. This would be an example of a binary compound, just 2 different elements. Barium nitrate, this would be a ternary compound, 3 or more. I would not worry about those. It's just fun bonus learning. Binary, ternary, that is. Calcium acetate, for the third one, silver fluoride, no Roman numerals, but copper 1 sulfate, Roman numerals for that last one. Hey, with the time you got remaining, if you need to be spending some time finishing up your study guide, if you want to make some flashcards, or if you're looking for extra practice, there's extra handouts in the tub above the goggles cabinet in the back. We'll be back for the test. If you have any last minute questions, feel free to stop by or email.